Okay, I'm just looking at the 3 diameter times 1.5 grease groove milled in this section here. So let's just quickly install that. So it's 3mm diameter times 1.5 deep times 85 long. So let's just pick a rectangle off here, and it's 85 long, and it's 3mm wide, that rectangle, because I'm going to get rid of half of it. And just before I get rid of everything else, let's just install a couple of circles that are there. Copy that from there to there, and let's just clean up now what we don't want. So there's our grease groove cut in. We know we have got coming in 20mm off there. Center line coming down through there. That has got a 5mm hole counterbored out to 10.2. So 5mm, and we want a 2.5 out that way, and we want a 5mm back. Let's now just select those two lines and make them solid. We'll just remove what's unnecessary. I'll just leave that like that at the moment. There is, of course, that line should be there. I'll just put that one back. That, of course, you still see in a section. So, if you think about this, I have got a diameter 5 hole intersecting a diameter 3 groove. So what I've just got here, I'm looking at the hole for the grease, and basically the grease nipple. It's a diameter 5 through hole. What I've just drawn here in the red is a top view. So that's your diameter 5 through hole. Sorry, that's your diameter 5 through hole. The distance between these two is 3mm. And that's your diameter 5 hole. So that's the red, that's the top view. I've drawn in the blue the end view. So that's, once again, 5mm apart. This here is, if it wants to play, radius 3, sorry, diameter 3, radius 1.5. And this one here is the diameter 62 inside of the bush. So let's have a look up here at this one. Looking at it in top view, that's your groove. The hole hits the outside of the groove at this point. There. I've just transferred that up. Let me change that colour to red. And of course, it also transfers it over there. So that is basically where the 3mm circular groove intersects. It also pitches up straight from the middle to somewhere there. Now let's come across and have a look at what's happening this side. Where that hole comes through and intersects, obviously at the very top here we have got one. Let me just pick a different colour, purple. We clearly have one point of intersection there. We have one point of intersection there. That we know. So where it hits end on, that obviously drills through there and drills through there. No brainer. But now it's drilling into open space here. Does not have any material in it. Let's have a look. Let's go to the other easy ones. This is the outside of that 5mm drill. That is where the 5mm drill hole finishes. So that we know. Is a point. So now we've got 3 points there. Let's have a look now at this intersection point. If you think about it, that's on the very outside of the groove. So that's at the bottom of the groove, which is here. That mark there intersects here. So that is basically saying where the two circles intersect. We have got a mark there. We've got a mark there. So let's now take out what we don't need, just before I delete everything. So let's go through that again. Looking at it from the top. That is the diameter 5mm hole. This is the edge of the 3mm land. So we know the edge of that 3mm land is up here. It travels somewhere up there on those two. Looking at it end on, that is the edge of the diameter 3mm land. So that's obviously the point of intersection, as is that. For this one, that's as looking at it in top view. There's looking down the 5mm hole. That is as far as it goes. That is the outside extremity of the 5mm hole. And this here, the bottom purple line, is the point of intersection between 5mm and the radius 62. That is obviously its intersection point. Okay, so I'm just going to draw this in freehand. It goes through that point. It goes through that point. And it goes through that point. Like so. Now, it clearly doesn't come down. I wish I could fix that in place. Instead, let me just drag that round now. So that is essentially how the intersection of those two holes drilled through the surface looks. That one there basically curves down like so till it gets to the intersection point. Then of course it flattens out because essentially I'm drilling a hole through an almost flat surface. So we're seeing something that's incredibly different to a circle, but that's somewhere close to, and it's still, I've only roughly put it in. It's roughly about that. Let me mirror that on the other side, then delete all the layout lines. Now, of course, up on top, we have an identical problem. I chose this one because we have this intersection problem as well. Here is a trusty toilet roll. As you can see, looking down from on top, I have drawn a circle straight above it. Now, as I bring the camera viewpoint down, you can see that hole, or the projection of where that circle is on top of a cylinder, where one cylinder meets another one at right angles. It produces something weird. That's essentially what you're making on top of the sheave, where you've got the 5mm hole drilled into a 112mm diameter outside of the hub. So coming back to that sheave again, we've filled in, that's the profile of the bottom where the bottom of that 5mm hole intersects through a radius 3 circle travelling horizontally and a radius 62 circle travelling horizontally with a distinct change in position because of the different radii. Up top we're going to have the same thing, but the first thing we've got is we've got to counterbore that out 10.2. What is a counterbore? A counterbore, they basically feed a cutter straight down guided by the original hole and cut out more. So that's what a counterbore is. Spot facing is they just stop at the surface, just to smooth out castings so you've got a flat spot for a bolt head to sit. Counterbore is exactly the same tool that just goes deeper. Like he says as he's looking for it, counterbores. That's not a counterbore. A counterbore. Diameter 10 through hole, counterbore, diameter 20, go down 8. While I'm at it, a diameter 10 hole going all the way through, that's what diameter 10 means, just a through hole. That V means countersink out to a diameter of 20 at a 90-degree angle. If it said out to a diameter of 15, then of course the top of that hole would be 15mm round. A counterbore, this is the one I was looking for. A counterbore looks like this. A counterbore is essentially a hole that's drilled. So that's saying drill diameter 10 all the way through, counterbore out to a diameter of 15, down 10mm. Countersinking, drill 10mm through, countersink out 90 degrees to an angle of to a diameter of 20 on the outside. So that's how you dimension features. Tapers you saw earlier with the taper pin. That's a 3 in 100 taper. So if a pin is 100mm long, if at one end it is 12mm, at the other end it is 9mm diameter. So it's tapered 3mm difference in diameter for every 100mm long. I'll just pick a random depth of 15mm at the moment. We can come back later and fix this up. You want to counterbore the minimum. When you counterbore that out, you're taking out strength of the shaft. So you want to take out the minimum strength of the shaft possible and leave it strong. That there, I come out 5.1mm and I come back 10.2mm, like so. Now once again, I'll use the same technique as I did earlier. From here I'll pitch out a 45mm. So I'm only going to have 1, 2, 3, 4, 5 points marked. Let's just have a look out the end here. Let's just draw the end view in blue. So there's the 112mm outside diameter of the shaft width, and I'll just copy and paste this across. There too. So that is showing the points of intersection of the shaft, as well as, I didn't put these in, 1, 2. Let's just now copy those across as well. So there's our 5 positions. That center mark here obviously is this outside line here because I'm looking at it side on. Think through your orthogonal views, please. That one there comes across to here. And let me just mark that in with a circle because lines will get confusing later, and I'll delete that one. The 45-degree lines become these two. Become those two, where the blue meets the blue, which is the reason why I picked the different colours. Now the outside is purple. That's the top of the shaft, that's the top of the 112mm circle, and that's obviously the top of the 112mm circle where those 2 points, or where that drill hole intersects. I've got the points marked. Let me just delete everything that's not relating to that original hole. said I was going to counterbore at 15 and come back and clean it up later. So let me just put in the counterbore. And of course, because I have got that counterbored, my diameter 5 hole is gone. So back we are, back with the counterbore. That hole's too deep. Later on I'll clean it up. But now we're just looking at how do you draw the intersection of the circle with a circle. It looks like so. Remove the stuff we don't need. That is now the intersection of a hole with a curved surface. A hole drilled through the sheave pin means laying out the intersection of a hole going into a curved surface. It's not a straight line, it's a fairly complicated curve to draw.